Alert! Alert! It's time to get in your bunkers! It's time to get in your bunkers! The sun is shutting down, folks! It's time to be spooked. Time to be frightened. We'll tell you all about why here on the Smash News Network, least busted name in news. The sun is shutting down, folks. Oh my God, to get in your bunker today. We've seen another reduction in sunspot number and the radio flux, which means it's bunker time. Get in your bunker now before it's too late. Pardon my sarcasm. That's the past 24 hours on the closest star. Viewing ionized helium from the Solar Dynamics Observatory, there is a huge filament fest going on, so you might see many dark features on there that are not coronal holes. Let's take a look at the northern hemisphere here and add 193 angstroms ionized iron. So you might see a bunch of snake-like structures there draped across the Earth-facing portion of the solar disk. Those are solar filaments, similar to these prominences up here, but on the Earth side. They are magnetic field suspended bits of plasma that are defying gravity, and they are often the origin of what we call coronal mass ejections. When huge amounts of the sun's atmosphere are blown off into space, causing things like the aurora, sometimes even power grid failures, power grid induction, telluric currents here on planet Earth. So there you can see a bunch of those filaments. We counted well over a dozen on yesterday's daily space weather video. We do have some active regions here, like this bright spot setting in the southwestern limb there above our Earth scale. That is a potential flare-producing sunspot region. A little bit of a crown prominence going on there at the southern polar area, as we bring you the most comprehensive daily space weather and the most detailed imagery of the sun you'll find in the known universe. If you enjoy the content, don't forget to press the like button. Yeah, press the like button and help us out with the ridiculous algorithm on YouTube. We need your assistance to get the content onto screens, so press like. The next most important one is to press share, I suppose. Press share, especially if you have some followers on social media. Press the comment button if these videos make you angry, especially make sure you leave a comment, because, you know, rage comments are like super important on the internet. So make sure you express how mad you are about all the facts that are portrayed in the videos. We appreciate that. Even leave derogatory comments, personal insults, maybe save any death threats or anything like that for someplace else. You might get banned from the internet. Who knows? You could be deplatformed, folks. It's all in good fun, right? Yeah, it's all in good fun. So yeah, press the like button. That's okay. We'll wait. You've pressed like? Okay. Wait. You haven't pressed like. You can see space right through my hand. Press the like button. Otherwise, the universe will find you, and the universe does not forgive nor forget. These videos, by the way, are brought to you in part by the Smash team. If you want to support the channel via our subscription service and paywall, become a member of the Smash team, you'll get additional content. There's a gold, there's a silver, there's even a bronze level. You'll even get email alerts about videos just like this one. Never miss a video again by signing up for email alerts from smashomash.com/smashteam, our own custom subscription services site that we built to replace Patreon, although we still are on Patreon as well. So hit us up over there. Other ways to support the channel are through merch. You can find a link to the merch below this video and save 25% on all apparel at the Redbubble shop. So make sure you check that out. Today's featured product is fast, cheap, and good. If you have a project manager who doesn't know what they're doing, they may think the project can be fast, cheap, and good. However, they would be incorrect. So select two. First of all, you can do a project fast and cheap, in which case it will be bad. So we recommend avoiding that choice altogether. And the two more viable choices would be a project which is fast and good, however expensive, or a project that is
cheap and good, but slow. So pick expensive or slow for your projects instead of bad by trying to have it fast and cheap, in which case it ain't going to be good. Again, save 25% on all apparel at the Redbubble shop. So that's today's featured product is Project Management Facts. Pick two. It's not going to be fast, cheap, and good. It's either going to be expensive, slow, or bad, or it's not going to exist at all. Project Management Facts. Another way to support the channel would be from the Hemp Lucid shop. So check that out if you haven't. The official Hemp Lucid shop of the Smash News Network least busted name in news is listed right below this video in the description. You can also find a link on our homepage at smashomash.com, so don't forget to visit that as well to find things like our social media links, link to the Smash Team site, link to the Redbubble site, even a permanent invite link to our Discord channel. So that's the best way to send an instant message, by the way, would be the Discord channel. You can also find us on Twitter, Instagram, Facebook, Threads for some reason, and X, the platform formerly rationally branded as Twitter. You can also find our Amazon shop over there, so check that out. Maybe get some eclipse glasses for the annular eclipse coming to Texas in just a little over 2 weeks on October 14th. Get the ability to look directly at the sun, just hanging out. A bunch of different eclipse shades there. Also, our radiation reflecting hat, pants, and shirt. Yeah, that hat, it reflects electromagnetic radiation, and I can prove it. That's the spacewear selection there at amazon.com/shop/smashomash, and let's head back to space to the SDO. Again, we see a reduction of sunspots, and keep in mind, folks, the sunspot number can be a little bit deceptive. If you've got a lot of sunspots on the opposite side of the sun, it doesn't mean the sun is super inactive. It just means there aren't a lot of sunspots on the Earth side of the sun. And, of course, we only count Earth-side sunspots. Since we can't directly observe the ones on the opposite side, we view them through helioseismology, which is because a sunspot creates telltale reverberations across the surface of the sun and allows us to take a very accurate, educated guess on where they are on the far side. So that's yesterday plus today, September 28th and 29th to date. Here's colorized magnetogram for that same period of time. And by the way, it looks like that sunspot that was rising over the northeastern limb has degraded, if not evaporated entirely. We'll show you a video about that later in the video. And let's take a look at volcanoes, as I want to see what's erupting. So it is one of our viewer preferences that we do go over volcanoes. Here's the world's tastiest sounding volcano, Stromboli, producing some lava fountaining there. So that's the first one on the list. Stromboli there, although the activity has been waning, has been producing some certainly interesting activity indeed. That information is from volcanodiscovery.com. Weak to moderate Strombolian explosions take place from the summit and remain unchanged. Mount Mayon also producing an unknown ash plume there over the Philippines. It is erupting, apparently. Ibu producing a 8,000-foot ash plume over Halmahera, Indonesia. And volcanic ash reported to 7,000 feet over Luatolo. Dukono, also on Halmahera, exploding, flight level 070 from Dukono as well. Popocatépetl looks like it's dormant, or at least no volcanic ash observed. Could just be cloudy. Nevado del Ruiz, new emissions over Colombia from Nevado del Ruiz. Sangay, new volcanic emissions over Ecuador. Continuous emissions from Revenador in that same country. Next, Sabancaya in Peru, exploding, flight level 260. It's a 26,000-foot plume of volcanic ash. And Villarrica remains at elevated activity levels. And some volcanic tremors happening there. Also, the warning bulletin states that pyroclastic flows, lahars, and or debris avalanches may occur. So please avoid the area around Villarrica. Next, we'll do earthquakes. We have been seeing the most earthquakes around the western Pacific Rim for the past about a week. So we could be seeing some pre-earthquake signals happening there. There's the 90-day bar graph. And we'll cite quakes of a 5 or greater magnitude. The largest of the past 24 was a 6.1 at Vanuatu. So that one did not produce a tsunami. It was at a depth of over 127 kilometers. That 6.1 was at 1440 Universal Time yesterday afternoon on September 28th. Also, northeast of Japan there was a 5.8 at 1740 Universal Time yesterday afternoon. And a couple hours later, a 5.7 at Papua New Guinea. As you can see, all of these quakes are around the western Pacific. 1943 had a 5.2 at Papua New Guinea. So that could be a pre-earthquake signal there north of Australia. Keep in mind, any earthquake can be a foreshock. There's another 5.5 at Papua New Guinea. That was at 1:19 this morning. And then a 5.0 at Papua New Guinea at 1:53 this morning. So lots of activity there around especially around the southwestern Pacific Rim. And it's time to head back to space. Space, oh my God, it's so spooky. Look at that, folks. The provider of all life and heat on Earth look how scary it is. Oh my God, I'm so spooked. The only thing scarier than a star, folks, is a galaxy. And if you know what I'm talking about. So that's the past 24 hours there from SDO 171 angstroms, the house favorite wavelength. Again, the radio flux and sunspot number have dipped since yesterday. So the 10.7 is now all the way down to 146, I think it is. 146 is the radio flux number now, represented by this black line over the past year. Space Weather Enthusiast Dashboard not forecasting any geomagnetic storms or geomagnetic unrest conditions, although we did get into mild geomagnetic unrest conditions this morning, primarily caused by magnetic field shifts. We'll show it here in a minute. First, Earth's magnetic moment from space for the past 4 hours. So we're likely to see this wane over this video right here as the magnetic field has shifted into positive BZ territory. We'll explain that in a moment. So this depicts magnetohydrodynamic pressure for the past 4 hours, and it should be reducing a little bit there, and indeed you can see that happening. Next, Earth's magnetic moment from the ground. Again, you'll see this calming down a little bit as well. It was a mild geomagnetic storm, geomagnetic unrest condition there. This will show you the most likely places to see the aurora, so we may see some auroral shares on the Twitter feed. No, I'm not going to start referring to the platform as X. I'm going to keep referring to it as Twitter, probably forever. The Twitter rebrand, the worst rebrand since New Coke. Who remembers that nonsense in the mid-1980s? Planetary K-index here. Again, we got to 3.67. It's going to drop down to like 2. The next update here, which shall be coming soon. KP 3.67 is the current situation when we produce the video. And let's take a look at what happened there with the real-time solar wind. So we did see an extended negative BZ signal. This negative BZ signal right here is what was mainly responsible for that. It wasn't a super strong field, it was just a strong negative BZ, which induces current into the earthly system. It basically pulls material into the Earth's magnetosphere, creating electrical current. So, when that happened, no big changes happening there to the solar wind parameters. They were pretty steady, and that has now shifted well into the positive territory. So the field stayed about the same, but the vertical component of that magnetic field has now shifted from negative to positive. So we're now at 8 nanotesla for the BT and positive 7 for the BZ. Solar wind speed here a little bit elevated at 479 kilometers per second. Solar wind density here just under 7.5 protons per cubic centimeter. That measurement is by the Discover here at the moment. The Discover, the active spacecraft. GOES magnetometers here, pretty chill. Keep in mind it is right around midnight local time for the GOES 18 there. And midnight local time is when you get the lowest readings on the GOES magnetometer, as it is around the least ionized material at that moment, because it's midnight local time for the satellite. Next, we'll look at the top view ecliptic plane field plot. And let's see what's going on here with that sector boundary crossing. It looks like it might be delayed again. Check it out. It's moving back out to the east, I think. Let's bring that back. Yep, indeed moved back out to the east there. So a little bit of undulation happening there. Again, it looks like the sunspot in the northeastern limb has degraded. So we expected a large sunspot to rise, and now it doesn't look like it's happening. So anybody's guess there. And look, the magnetic environment can change with basically no warning. So at least the top view ecliptic plane field plot gives us some idea of what's going on the eastern limb, especially thanks to Stereo B's measurements. This data is based on 51 ground-based magnetometers, and magnetometers on Stereo B over here and Stereo A over here. So that's the heliospheric current sheet. Sector boundary crossing still probably about 48 hours at least off. And next, let's take a look at the line of sight field plot. There you go. Solar B field in blue. The B field being the field that goes through the magnet, this magnet being the local yellow dwarf. Here is our line of sight coronal hole plot. We've got North Pole oriented coronal holes here at the moment, facing Earth. Here's the view from SDO. That is the past 24 hours. So these are all North Pole oriented coronal holes. And we are expecting to see a minor uptick in solar wind from this coronal hole in about 4 days. So that's the only real space weather on the way as far as we can tell from the available imagery. And that brings us to sunspots. Sunspot number here dipping down toward 100. There you go. There's a sunspot number from the Royal Observatory of Belgium. Sunspot number here now at about 109, it looks like. And here's the situation from our flare monitor and flare scoreboard. Most likely places for flares are this group right here. And this group down here, I would also say that 3445 setting in the southwestern limb is a candidate to produce some flares. Anyway, let's take a look at sunspots here from SDO. Here we've added 171 angstroms to the SDO continuum to highlight the active regions. Again, that area up there in the upper left, the northeastern limb, does not appear to have a sunspot back there anymore. It looks like it's degraded in the past couple of days. There could still be some small pores there, so we'll be keeping an eye on it. And when I say eye on, pardon the pun. Here's the SDO continuum by itself, and those groups look like they've been mostly stable. No sudden sunspot growth, no sudden sunspot degradation. And here is the magnetogram. So that's the scenario for sunspots. Next we'll move to solar flares and energetic particles, which has also been flatlined. So base levels there for the GOES proton flux, no solar energetic particle events of note. X-ray flux has been dipping as you would expect with a lower and lower sunspot number and radial flux. Current background levels are still at about a C1. A C1 background flux. Only one M-class flare here in the past 5 days. So a little bit of underperformance there. Keep in mind, folks, you can forecast solar flares. All you have to do is take a look at the magnetic orientation of those sunspots, and you too can forecast solar flares by examining the magnetic shear of them. Anyway, here's SDO 94 plus 131 angstroms. So we do have some decent potential for solar flares. I would say mainly in the southeastern and southwestern limbs. So down here and down here are my favorite spots for a significant solar flare. There is still some chance up here also, as I do see some activity and plasma instability there. Some chance over here as well. Let's take a look at there's the 94 angstroms wavelength by itself. There's another 24-hour video of the southeastern limb. That sunspot does have some complex fields, and it has produced some flaring activity, as you can see. And we've also got here we're back to 131 plus 94 angstroms in the northwestern limb. Some potential for flaring up there. In my opinion, the most likely spot to see a large flare at the moment for the next 36 hours or so, maybe 48 hours, would be down there in the southwestern limb. It has to do with the proximity to the limb, and our regular viewers are probably well aware that large solar flares are more likely to happen close to the limbs. Speaking of close to the limb, there's an extreme close-up of that setting sunspot. It will still be capable of producing large solar flares for at least 2 days. Keep in mind, large sunspots that have complex magnetic fields can produce large flares long after they've set out of view. Speaking of setting out of view, this is what's going on overhead Lehigh Valley, Pennsylvania. Jupiter is setting over there on the western ecliptic, being chased by Venus, Mercury, the Sun, and indeed Mars. That's our current situation, our star chart overhead from skyandtelescope.org. Put in your location and make your own star chart if you like. And here's your solar system forecast for the next week. If you're wondering where things are, that's where they are today. That's where they'll be on the 6th of October, when we'll be wishing Smash staff a happy birthday. Continuing on, to check it out, folks. It's a capsule from space. It's the astronomy photo of the day. That is the OSIRIS-REx sample capsule. It's about 31 inches in diameter. It weighs about 110 pounds. OSIRIS-REx's sample capsule returning a record amount of material from the asteroid Bennu, sitting there in the Utah desert, awaiting its collection. And of course, we're awaiting the opening of this, which is still a few days off. I suppose they probably have to fly in members of the team. How exciting is that? Getting to play with rocks from an asteroid. apod.nasa.gov, by the way, if you want to check it out yourself. Next, we got an article about cosmology. Yeah, a brief article on cosmology, because Supernova 2023 something or other, Supernova 2023 IXF, has done some things that are calling into question the concordance model of stellar evolution. Who would have thought? Since practically every observation calls into question the concordance model of stellar evolution, including observations both of our own sun as well as stars in different galaxies and so on. But what sets this one apart is that it experienced massive mass loss quite a while before the supernova went off. So, of course, If you're a regular viewer of the channel, you may already realize that supernovae don't appear to destroy stars. However, people still seem to be assuming that supernovae destroy stars. If supernovae destroy stars, how come in the center of every supernoval shell we see lies a star? That's kind of interesting, wouldn't you say? So anyway, yeah. So this is yet another blow to the concept of the concordance model of stellar evolution. One of the theories is that as this red supergiant burned off silicon in its core, it became unstable, and it lost an amount of mass similar to the mass of the entire sun. So, red supergiants are believed to be stars that are 8 to 25 times the mass of the sun. You can find this article on scitechdaily.com. And yeah, so this supernova produced a light curve that doesn't seem to fit its expected behavior. Of course, again, we see a lot of behavior that's not expected from stars, including the emission of a white light spectra and all kinds of other things that indicate the concordance model of stellar evolution is probably not correct. But in any case, yeah, this one, it lost an excessive amount of mass, atypical of type 2 supernovae, close to the mass of the sun in the final year prior to explosion. So there's an image of it in the Pinwheel Galaxy. Supernova 2023 IXF. The article on scitechdaily.com is referring to a paper studying that mass loss. Again, if you want to read that, it's at scitechdaily.com. That observation was from the Fred Lawrence Whipple Observatory on June 27th, 2023. So go have a read if you like about Supernova 2023 IXF. And let's take a look at coronal mass ejections. So here are a very large number of frames from yesterday, September 28th. For some reason, 180 frames there. And there are some minor CMEs there. There certainly is a potential for coronal mass ejections right now, as there is a huge amount of plasma oriented right at the Earth. We're going to show filaments here in a minute. Things have been very calm in terms of flaring, sunspots, radio flux, and coronal mass ejections for the past 24 hours. So those are yesterday's images. Here are an additional 71 images from today, September 29th. Again, only some minor outflows there. Soho Lasco C2 and C3 is missing some data there. Let's take a look at there's a better data set. Let's take the C3 and move this through September 28th. Oh, not very many frames there at all. So let's rock back the C3. Not a lot going on as far as coronal mass ejections. We'll also show stereo A. We like to show this screen daily because it shows where stereo A is located, as it is now actually getting some better angle as it moves farther and farther from Earth. It orbits a little bit faster, so Earth orbits in this direction, and so does stereo A, but it is closer to the sun, so it orbits a little bit faster, and it'll give us better and better views and better ability to calculate the trajectory and velocity of coronal mass ejections. So here are the available frames from stereo A. And again, based on the coronagraph data that we see here, we do not expect any earthly directed coronal mass ejections. Based on that, next we'll look at filaments. And again, the filament count is pretty berserk, folks. Look at all those dark features. That is not only a lot of filaments, but very large filaments. So, I mean, without even looking at the ones that are prominences, that is filaments that hang off the edge, look at how many filaments we have here. So there's at least 1, 2, 3, 4, 5, 6, 7, 8, 9. There's at least 10. This one over here is setting. It's probably also a prominence. At least 10 filaments on the Earth side of the solar disk. Several of these could become earthly directed coronal mass ejections. Here's the gray imagery, which does show prominences. You'll see a few extra spots there overlapping the edge of the solar disk. Those are the same feature. And so basically the point is, folks, that the sun is very bumpy. The sun's atmosphere, the corona, it's very bumpy. And the strong magnetic fields associated with it are suspending material, which could eject. And remember, folks, I say it all the time on the channel, coronal mass ejections and solar flares are completely separate phenomena. Don't get them confused. A solar flare is photons of the X-ray frequency. Photons. Coronal mass ejections are protons. Physical matter, not electromagnetic radiation. Actual matter, mainly hydrogen nuclei, about 90% hydrogen nuclei, like 12% helium, and the rest is other heavier elements and electrons. Coronal mass ejections are physical material blasted out of the sun's atmosphere. They are what cause things like geomagnetic storms. Solar flares are X-rays, which are just high-frequency light. So, again, solar flares are photons. Coronal mass ejections are protons. We hope everybody understands this. And by the way, we will be naming filaments today over on the platform formerly known as Twitter. If you want to follow the hashtag #NameThatFilament, all you got to do is just take an image, let us know which filament you'd like named, tag us in a post, like that, and you can name that filament after a living person. Who should we name them after? So that's some incentive for you to follow us over there on the platform formerly known as Twitter. Oh, brother. Yeah. And thanks to our followers over there on Twitter, we have one less than we did yesterday. Next, we're going to show the past couple of hours from the GOES 16 SUVI. Let's shrink that down to 90% to show the extended corona there. We still do have a crown prominence. Huge filament over here around the eastern equatorial region there. That is a prominence and a filament. And let's get the bonus features. First bonus feature is charging hazards for satellites. We have some surface charging there that's caused by high energy electrons. Actually, that's low energy electrons. I apologize. Low energy electrons there building up on the outside of the spacecraft. Those cause communications errors, usually not any satellite damage. They are significant surface charging hazards there over the eastern Pacific, Mexico, Central America, and moving into the central Pacific Ocean. GOES electron flux here showing pretty low levels. Keep in mind that is around midnight local time for the GOES 18, represented by that red M. The N represents noon time for the GOES 18. So we're just moving into warning levels here, so we're expecting fairly high levels of electron flux. There's the one-year graph of the relativistic electrons reported by Solon.info, and there is the forecast model. Looks like NOAA is forecasting a decrease there. I'm not so sure that one will be correct. That green box is the next forecast. The yellow diamond is the observation. Moving on to the ionosphere. And we'd like to show this image daily because some people don't really understand the temperature inversions, which are depicted over there where it says stratosphere, mesosphere, thermosphere. You see the way the troposphere is warm at the bottom and cold at the top. The stratosphere is cold at the bottom and warm at the top, and so on. Thermosphere, cold at the top, bottom, warm at the top. Those are the temperature inversions of the different atmospheric layers. The center portion is the penetration of electromagnetic radiation through atmospheric layers. For example, the X-rays never make it to the stratosphere. That is why we need spacecraft to detect solar flares. You can't detect X-rays from the ground level. Or on the right side of that, you can see the way visible light and infrared light makes it all the way to the ground level. Last but not least, on the right side, it's depicting chemical densities in different atmospheric layers. And also, chemical densities in different atmospheric layers. So here is the ionogram for the previous day. And this is the F layer located up here at about 300 kilometers of altitude. It's the bridge between Earth and space. Why? Because we're zooming into the Earth to get to our meteorology segment and go from space weather to Earth weather. Here's the anomalogram depicting anomaly in megahertz from a 30-day median in that same layer, the F layer of the ionosphere. And it's quite calm and normal. There is absolutely nothing to be spooked about when looking at the ionosphere. No matter what hack fraud space weather wannabe channels will tell you about it, I have no idea what they're talking about, and neither do they, because they're spouting nonsense. Don't be scared of the sun, the galaxy, or the ionosphere. It's not scary in any way. There's the latest ionogram, 11:45 Universal Time, and there's the anomalygram. Oh, look at all the blue. It's high-frequency anomaly, folks. Quick, get in your bunker. Oh, noes, get in your bunker, folks. I'm spooked of the ionosphere. Anyway, here's our, I like this one. This is showing multiple different things here. It's showing the usable radio frequencies there as radio signals sort of refract off of the ionosphere. The ionosphere acts like a mirror, kind of, for the radio signal. So that's going to show you the usable radio signals and the timestamps, the total electron content, and the total electron content anomaly. So I like this map. I think we're going to pick it up as a regular map. And it is actually showing you a forecast for tomorrow as well there. We'll also show the total electron content by itself. That's free electrons from about 12,500 miles of altitude down to ground level. And hence it'll show you the most likely places to see errors in your GPS. And folks that live around the equator are well aware that around noontime especially, their GPSs will not work. We also show total electron content anomaly over North America. There is the total electron content anomaly for the 10-day average. It's literally a count of electrons. And we are seeing some high electron contents there around the west coast of North America. They are fairly minor. And we'll close out space weather. Oh, I almost forgot. So, this is your helioseismology. And the grayscale portion, what that is depicting is the Earth side of the solar disk. And that blurrier gold-colored portion, that is depicting the far side of the solar disk. So that is how you can take a look at what's going on the far side of the sun. And like I said, in the past couple days, and basically what you're seeing here, this is the west side, and this is the east side, as this is sort of the rising solar disk, if that makes sense. And yeah, we've seen degradation of those sunspots on the far side there. So there may not be sunspots rising in the northeast after all. There is a little bit of activity rising, so let's take a look at that once that plays through one more time for you. Here's the latest intensitygram and the latest magnetogram. We do see a plage rising over here. It does not appear to be a sunspot. There are the rest of the sunspot groups in colorized magnetogram. There's the intensitygram, or SDO continuum if you prefer. And let's move to meteorology. We're going to go wave chasing. So let us know in the comments if you like going wave chasing. It's one of my hobbies. And the largest waves in the world right now are in the northern Pacific. We've got about 35 footers up there. Those are the stormiest seas in the whole world. Some honorable mentions there in the Southern Ocean. West of the Drake Passage especially. So the seas are fairly calm here at the moment. But 35 footers there south of the Aleutians. Let's take a look at air masses here as we move to meteorology. Surface winds are depicted here. Shout out to our viewers from the east side of planet Earth. There are the jet streams for your eastern Earth. Shout out to our viewers from the central world, Europe, Africa, and the Middle East. Those are your jet streams. Here are your surface winds. Surface winds from the west, depicted here. This is, by the way, this is nullschool.net. Check out the fantastic Earth wind map yourself if you like. Nullschool.net. You will not regret viewing the surface winds over there. Shout out to our viewers from the west side. And there is the jet stream scenario for Western Earth. Next, we got a pressure map for you here. This is the mean sea level pressure. And yeah, that's what's going on. And by the way, thanks for tuning into the Smash News Network, least busted name in news. Huge anticyclone down here in the southern Pacific. You can see that counterclockwise rotation, as is the standard modus operandi for upper-level high-pressure systems in the southern hemisphere. Lowest pressure in the northern hemisphere is certainly in that area with the stormy seas there south of the Aleutians. 973 hectopascals down there. And moving right along to our clouds and fog map. That's shortwave infrared radiation over the Americas. And those lows in the subtropical Atlantic there are just stagnating as we forecasted. They are entrained by not only high-level wind shear, but also Saharan dust. We've got some flooding up the east coast here, especially North Jersey and southern New York and parts of Connecticut. Also New Mexico, Minnesota, and up the east coast there, some coastal flood advisories. We'll briefly scroll down to show you the key. Weather.gov is where to go to get your weather alerts if your location is lit on the map. Those are too many counties for us to cover, but here come some forecasts. So first we'll show the pressure and precipitation. A little bit of snow here coming to Nevada, Idaho, Montana, Utah. 72-hour GFS pressure and precipitation forecast. Here is GFS 72-hour total accumulated precipitation forecast in inches. Heavy rains there coming to North Jersey, the Big Apple, Connecticut, and southern New York. Expecting up to 4 inches there, maybe 4 inches plus in some of those areas. Also Massachusetts is going to get heavy rain. That's your 72-hour GFS total accumulated precipitation forecast in inches. And also there's a cold snap that's going to go across the U.S. here, caused by cold air from Canada. Look at the jet stream kinking way down, creating this huge 180-degree bend, injecting cold air all the way to Mexico. So there'll be a wave of cold there sweeping across the U.S., now making the news stories. That is the GFS 72-hour 250 millibar wind speed, otherwise known as the jet streams. So that should help with forecasting, right? Next, your lightning mapper. This is the Smash News Network, least busted name in news. That's the past about 10 hours of lightning. And let's check current terrestrial strikes. I believe we have some here. Just west of the day-night terminator, St. Paul has some thunder surrounding it. Some thunder rolling in there. Also the North Dakota-South Dakota border, the eastern portion of it. Seeing some active cells happening. Looks like a severe thunderstorm there. That is a lot of strikes. Current worldwide lightning total. Pretty active there at 663 strikes per minute. Once again, if you enjoy the content, press the like button. Visit our links. Hit us up on social media. If you've got a question, concern, or who knows, a criticism, hit us up on Discord. If you've got auroral imagery that you'd like to share, there are ways to do it, like social media. We're all over the internet. At Smash-O-Mash. Give Smash staff a raise by becoming a member of the Smash team. Pick up some merch. Save 25% on apparel from the Redbubble shop. We built these sites for people like you, partially because of the pathetic censorship on the internet. There's the link to Redbubble, Spotify, original music over there, Hemp Lucid. There's the Amazon link, the Twitch channel, Discord, Facebook group, Threads for some reason, Instagram, Facebook. And, of course, the YouTube channel. Anyway, we'll close out with U.S. Doppler radar, clouds and fog, and water vapor, as we're wont to do on the channel on the regs. Check out this heavy precipitation here. And there's going to be a second wave coming, by the way, folks. So that's going to add insult to injury. And look at this severe thunderstorm. That is a supercell moving to the northeast. That is a very highly concentrated storm there. And there's a second one right behind it that's going to cause some training. It's going to strike a lot of the same areas. Anyway, there's what's going on in terms of vertical motion in the air column, ground-based systems known as Doppler radar. Here's a space-based system depicting infrared radiation. It shows clouds and fog even at nighttime. And there is the water vapor map. That should clear things up if it's a little confusing on your Doppler. And we've got a mass of dry air here over the southeastern U.S. Anyway, here's your recap. U.S. Doppler radar for the lower 48. Clouds and fog. And there is water vapor. Anyway, thanks for tuning into the Smash News Network, least busted name in news. We'll come back and do it all again tomorrow. Eyes, no. Open, fear. Beware of cults, folks.